In today's Algebra 1 video, we're going to learn to factor trinomials. It's very helpful to have strong multiplication skills, to know a lot of facts about what multiplies to make what. For example, in this first problem, if you know all the whole numbers that multiply to make 20, what they call factor pairs, this will be pretty easy for you and it'll go quickly. However, I'm going to assume you don't know a lot of that, and I'm going to teach you today how to use a calculator to help you with this process. When you factor a trinomial, like x squared plus 12x plus 20, you'll notice that there's 1, 2, 3 terms separated by 2 plus signs. And the factorization of this is a product of two binomials. And we're going to come up with an answer, and then I'm going to show you how to check your work to make sure it's really correct. The two binomials look something like this. The reason you have to have x's here is because when you check your work, you're going to multiply, among other things, x times x, and that's how you're going to get x squared. Now the numbers here are going to be whole numbers, typically, that multiply, in this case, to make 20. So if you want to factor this thing and you want to do it efficiently, the first thing you want to ask is, how many different ways are there to multiply to make 20 using whole numbers? Well, there's 1 times 20, 2 times 10, and 4 times 5. And you could use products of two negative numbers here, but today we're going to leave minuses and negatives out of the discussion. We're just going to make this as easy as possible. Now, among these three possibilities, only one of them is really going to help you factor this, because the numbers that go here not only have to multiply to make 20, you'll see when we check our work, they're going to have to also add up to make 12. So if I weren't multiplying, but I were adding, like this, that would make 21, that would make 12, and these two would add up to 9. So apparently the 2 and the 10 are the numbers that do the job. They actually do two jobs. 2 times 10 makes 20, and 2 plus 10 makes 12. So now we have our trinomial factored as the product of two binomials. Now this problem's done, and it's correct, and now we're going to show you that it's correct. This method of checking your work, you don't need to do this every time, but I would encourage you to do it at least a few times so you can get the feel for this. You're going to distribute this x over here, x times x, which you should know makes x squared. You're going to multiply x times 10, and that just makes 10x. Then you're going to shift your attention to this 2, and you're going to multiply 2 times x to get 2x, and you're going to multiply 2 times 10, and that makes 20. And then when you total these columns, in the x squared column, there's just x squared. In the x column, 10 plus 2 makes 12, and the power does not go up. It's still an x, not an x squared. And then in the constant column over here, you get 20. Well, we were able to get back to where we started, so we must have factored it correctly right here. Okay, we're going to do one more problem here before I show you how to use a calculator. The calculator is very handy in coming up with ways to multiply to make the number on the end. The whole problem always starts with you coming up with this list, whether it's on paper or in your head or on a computer screen or with a calculator. So let's shift our attention to this problem now. I want to factor this trinomial. It has 1, 2, 3 terms separated by 2 plus signs. It's going to factor as a product of binomials. And I think on every one of these problems today, we're just going to have x here and x there. We can worry about more complicated things later. But over here today, we're going to have whole numbers. We won't worry about negatives or minuses. We just want to know numbers that multiply to make 30. Now, the first thing that comes to mind might not be the correct combination. When I ask what multiplies to make 30, many of my students say 3 times 10. They're not wrong. That's a way to make 30. But it's just one way, and you have to get the correct way. Now, here are all the ways to multiply to make 30 with whole numbers. 1 times 30, 2 times 15, there's one that not everybody thinks of. 3 times 10 is a good option, just not for this problem. 5 times 6 makes 30. So how do you know which combination out of these 4 pairs, which ones go in here? And the answer is you just have to shift to addition. Whether you do this on paper or in your head, you've got to go through all 4 possible pairs, and you got to add the factors. And you've got to come up with a combination that adds up to 11. Well, it's 5 and 6, isn't it? 5 times 6 makes 30. 5 plus 6 makes 11. And so one more time, we're going to write down our answer and check our work so that you can see how the 5 and the 6 help you make the 11x. And I think this will be the last time I do the checking of the work. Checking of the work basically means multiply all this out and see if you can get back to where the problem started. If you can, you did it right. If you can't, something went wrong. So cover up this 5 and multiply through this with this x into this binomial over here. Yeah, you have to distribute this. So first x times x is x squared. X times 6 is 6x. You're done with this x now because you've used it twice. So now multiply through with this 5. 5 times x is 5x, and I always like to put that right under that 6x. And then 5 times 6 is 30. 5 times 6 is 30. But 5 plus 6 is 11. So you can see how the numbers 5 and 6 multiply to make the number on the end. But you can see that in the x column, we added these things to make 11x. And there's no combination over here that multiplies to make 30 that would also help you get 11. For example, the 2 and the 15. If I had 2 here and 15 there, I'd get the 30, all right. 2 times 15 is 30, but I wouldn't get the 11. 2 plus 15 is 17. All right, here are 4 problems that all have the same last number, the same constant, 24. What this means is, and I don't see any minus signs or negatives here, I'll be able to make one list for this problem, and I'll be able to use the list for problems 3, 4, 5, and 6, and that'll save us a lot of time. Now, I mentioned that, for example, in the previous problem, if you don't know all the different combinations of factors that multiply to make 30, well, that's okay. There's a way around that, and I'm going to show you that right now. How to come up with the complete list of positive whole numbers that multiply to make 24. There's a lot of them. First, you get a calculator. And then you take 24 and you divide it by 1. You may think that's silly, but because this came out to be a whole number, that shows you that 1 and 24 multiply to make 24. Now just start going up the list. 24 divided by 2. That's a whole number, isn't it? So 2 times 12 makes 24. Try 24 divided by 3. Wow, another whole number. Well, that gives you another combination, 3 times 8. Try 24 divided by 4. Another whole number. 4 times 6 then is a different way to make 24. Now you notice how these are about the same size? That could mean that we're about done with this. If you try 24 divided by 5, you don't get a whole number. So 5 times something is not going to be in our list that I'm about to make. And if you try 25 divided by 6, well, we already got that one. Oops, wrong thing. Start over. It was 24 divided by 6. Well, a minute ago, we already had a 4 here and a 6 here. So let me write down the list now. And this is the list, again, that's going to get used on all 4 of these problems. We just saw that 1 times 24, 2 times 12, 3 times 8, 4 times 6 all make 24. And if you go past 4, you'll get a 5 that doesn't work, and then you'll get a 6 that goes with 4, and you've already got that. So this is the end of the list. There's 4 ways to do it. Isn't that interesting? There's 4 different problems. Now this time, instead of writing down all the additions associated with these multiplications, I'm just going to do that in my head. Yes, 1 times 24 is 24, but what is 1 plus 24? That's 25. This problem has 24 on the end, but it also has 25 in the middle. So I think that the 1 and the 24 are the numbers that are going to get used to factor this. So this answer is going to be x plus 1 times x plus 24. Now go up to this one. 2 times 12 is 24. The remaining problems all end in 24, just like this one. But where do the 2 and the 12 go? The answer is only for one of these problems are those the appropriate factors. So change to addition, 2 plus 12. 2 plus 12 is 14. And notice that this problem has 24 on the end, but it also has 14 in the middle. I think 2 and 12 are the correct numbers to use in the binomial factors of x squared plus 14, x plus 24. So that looks like this. Okay, problem 5 and 6 are done. I've used those two. 3 times 8 is 24. What is 3 plus 8? 3 plus 8 is 11. We're going to use these to build the binomial factors of this. X plus 3, x plus 8. And finally, well, 4 times 6 is 24. 4 plus 6, 4 added to 6 is 10, and that works there. Okay, we're going to do 2 more problems, and this is a short video. The next 2 problems do not use the list for 24. This won't be any good to us anymore. And how do I know that? Well, because the last number here is 40. Also on this problem is 40. So what I need to do now is make a new list. If you can't do that list in your head, remember there's a way to take a calculator and do it. You just go 40 divided by 1. Keep track of the answers that come out to be whole numbers, like 1, 40, 2, and 20. Because you're going to get a bunch along the way that are not, and you want to discard those. We won't be using 3 in our list of factors of 40. But 40 does divide by 4. 40 does divide by 5. 40 does divide by, no, it doesn't divide by 6, does it? So while you will have 4 times 10 and 5 times 8 in your list, you will not have 6. So we tried 6. We can try 7, and it doesn't work. The next thing to try is 8. But wait a minute. We already had 5 and 8. So, yeah, we were basically done when we got to the 5. Here's the results of what we just saw. 1 times 40, 2 times 20. Not 3, that won't work. But 4 times 10 and 5 times 8 are all ways to multiply with whole numbers, not using negatives, to get 40. Okay, well, hopefully something here will help with x squared plus 14x plus 40. And the answer is yeah. You can factor this like this and just pick the correct combination out of these 4 possibilities for this. Well, they all make 40. But this one adds up to 14. 4 plus 10 is 14. So once you've got this list, this is how, looking here is how you pick out the correct combination. X plus 4, x plus 10. A different combination is useful for this problem. If you want to factor this, you're going to go x and x, pick out a combination that multiplies to make 40. But it also has to add to make 22. And that is 2 plus 20. So, put plus 2 here, plus 20 there. Now, I'd like to make a suggestion. If you're the kind of student who can come up with this list without looking at a calculator, there's a good chance that you can get a lot of these problems right in your head. If you're the kind of student who needs a calculator to come up with this complete list, you've got to go through that process that I showed you with the calculator, and you have to write the list down, or you're just going to miss things. You're going to plug in the first thing that comes to mind. For example, solving a problem like this, you'll say, oh, there's a 40. 5 times 8 makes 40, and you'll put a 5 here and an 8 here. But that's not the right combination, because 5 plus 8 is not 14. 5 plus 8 is 13. This list really helps. I've been teaching this a long time. You should take my advice. Anyway, that's it for the day. Hope you enjoy this. My name's Eric. Have a good day.